Here we have the integral of x over the quantity x plus 3 dx. We're actually going to solve this problem in 3 different ways just to show some different methods. The first is going to be a substitution. So we're going to let u be x plus 3. The denominator, du, is then equal to dx. So we'll be able to replace our denominator with u. We'll replace our differential dx with du, but we will not have replaced x at that point. So we'll need to solve our original equation for x. So if I subtract 3 from both sides, u minus 3 is equal to x. And so we'll do our change of variables. Our numerator will be u minus 3. Our denominator will be u. And our new differential will be du. Now we can split this up. Originally I had just a single term on the top and a sum on the bottom, which we can't do anything with. But now I have a single term on the bottom and a difference on the top, so I can split this up. And I would be left with u over u minus 3 over u du, which is just 1 minus 3 over u du. The antiderivative of 1 is u. The antiderivative of 3 over u is 3 natural log the absolute value of u plus c. And then if we plug our u back in, our u was x plus 3. So we'll have x plus 3 minus 3 natural log of the absolute value of x plus 3 plus c. So this is method 1, a change of variables or U-substitution. So here we have the same integral, the integral of x over x plus 3 dx, but we're going to solve it in a different way. Here's what we're going to do. We're going to rewrite this. So I'm going to leave the quantity x plus 3 in the denominator and the differential dx. In the numerator, I'm going to have my x there, but what I'm going to do is put next to it a plus 3 and a minus 3. Which truly doesn't change the problem. Plus 3 minus 3 is just 0. But it's going to give me a way to rewrite this problem. So what we're going to do is we're actually going to split it up. And that's not very obvious because we're used to splitting things up when there's one term on the bottom and there's a binomial on the bottom. But what I can do is I can take x plus 3 over x plus 3 minus 3 over x plus 3. So it's going to look like x plus 3 over x plus 3, the same quantity over the same quantity, minus 3 over x plus 3 dx. So we're just integrating 1 minus 3 over the quantity x plus 3. Well, this is nice. The antiderivative of 1 is just x, and the antiderivative of 3 over the linear function x plus 3 becomes 3 natural log absolute value of x plus 3 plus c. And that's it. Now, if you compare it to our previous answer was x plus 3 minus 3 natural log absolute value x plus 3 plus c. So the difference is there's this extra plus 3 in our previous answer. But it turns out it's the same as what we have here because our generic constant is meant to encapsulate any constant value. And so we can really just lump this plus 3 in with the generic c. So in the previous answer, in other words, we could have elected to not write plus 3 and just said, oh, that's included with any generic constant. So these really are equivalent answers. Finally, the same problem one last time with a third strategy, and that strategy is going to be to use long division. So here I have this rational function, a polynomial divided by a polynomial, and this is considered an improper rational expression because the degrees are the same. So if the degrees are the same, or if the degree on the top is bigger than the degree on the bottom, I have an improper fraction or rational expression here. So we can do long division. We can divide the denominator into the numerator. So we're going to take x plus 3 and divide that into x. And so if you remember long division, we take x and we think about, well, x times what value is going to get me to x? Well, it turns out that's just 1. And then we multiply. So we have 1 times x, that's x, and 1 times 3, that's plus 3. And with long division, we subtract down, so we're going to change those two signs. And so x minus x is 0, and then I'm going to have a negative 3 left over. And this is called the remainder. So the answer to x divided by x plus 3, that's what we're doing here, x plus 3 divided into x, is a quotient of 1 plus the remainder over the divisor. So here, x over x plus 3, it turns out is 1, again, the quotient, and then plus the remainder, which was negative 3, over the divisor, x plus 3 dx. So this is more of a review of long division than anything else. So again, the quotient plus the remainder over the divisor, if there is a remainder. And so if this integrand is equivalent to this, then we can just integrate piece by piece. So we get x minus 3 natural log absolute value of x plus 3 plus c. So 3 different ways to find the same integral.